Hi, everyone, and welcome to Get Your Head Out of Your Assay, the show where we talk with assay experts about the nuances of assay development and factors that go beyond the well and protocol. Today, I am joined by Melanie Leveridge, Vice President of Assays, Profiling, and Cell Sciences at AstraZeneca. Today, we're going to talk about ligandability, what it means, what it tells us about a target, and how to assay for it, and why it's important to consider before launching a full drug discovery program.
Well, I appreciate you doing this.
No problems.
This is fun for me because I've been following your career kind of in parallel for so many years, having you seen present at all these different conferences. And one of the things that you've presented a few times, but that always kind of sticks in my head, is this idea of ligandability.
Mm-hmm.
Right, and it's a term that I think I've heard you say it more than anyone else, and so I'm curious to learn a little bit more about what it means to you and how you're using that to inform on some of the drug discovery programs that you've run. So maybe to start, can you define what ligandability means and how it differs from drugability?
Yeah, sure, and I think that is a really important distinction, actually, and we probably use them too interchangeably. So when we talk about ligandability, we're really talking about molecules binding to a target. So how readily can we find molecules that bind to our target of interest in a desirable way? So not just stick, but stick in a kind of desirable way. So that's one part of drugability. Obviously, you need to be able to find molecules to progress a drug discovery project, but drugability is way more than ligandability. So obviously for drugability, you need lots of other factors like relevant safety profile, expression in your tissue of interest, understanding of obviously the biological target validation and so on. So ligandability is one piece of the big puzzle that is drugability, but it's an important piece, and it's important to understand going into a new drug discovery project how big a challenge that's going to be, and it can help you steer towards what modality might be most relevant. It can help you understand what level of risk you're going to carry and so on.
And so if you're starting a program, how can people measure? What are some practical ways that people can use to evaluate ligandability?
Yeah, so usually, as I say, you're looking at binding at that early stage. So this is typically done as either very early in a drug discovery project, or even before you actually commit to a full-scale drug discovery project. So you really want approaches that don't have a lot of assay development. You don't want to spend months and months, developing an assay just to do a kind of quick ligandability assessment. Mm-hmm. And the other advantage of binding assays, affinity assays, is they allow you to kind of probe the target protein of interest in a pretty mechanism and binding site agnostic way. So obviously that's going to depend on the protein construct that you've got, but you can find things that bind in all sorts of places on that protein. So generally you're talking about affinity methods, and so that would be, for example, SPR, surface plasmon resonance type assays, spec-based assays, affinity selection, mass spec, or maybe DNA encoded library DEL approaches. Although usually if you're just looking at ligandability and you're doing DEL, you wouldn't then typically do the off DNA synthesis. So you'd just be measuring kind of on DNA binding in a DEL assay. And what they all have in common is they don't require tons of assay development, and you can probe your protein in a kind of mechanism agnostic way.
And so when you're setting up some of these assays, what types of signals should researchers be look for? And when I think about, you mentioned SPR, one of the questions that always comes up when people are evaluating small molecules, in particular binding to targets, is super stoichiometric binding versus kind of a one-to-one stoichiometry. So what type of signals should people be looking for that assesses ligandability more than just seeing what sticks to the target?
Yeah, you make a really good point. So, I mean, as you said, at the start, it's productive binding that you want to measure, specific binding, not just anything that sticks. The first thing I'd say, actually, even before you get to the binding experiment, that we need to really be conscious of is the quality of the protein reagent. So these experiments will tell you as much about the feasibility of making a quality protein as they will about the kind of binding ligandability. So generally we might look at this type of experiment with multiple different protein constructs, and you need to be sure that you've got a quality protein reagent, that it's not misfolded. You understand if you're looking, or if your target wants to be in a monomer state or a dimer state, for example. So I think that's really important, first of all, that you've got a quality reagent going into these experiments. And then obviously from the binding itself, you're looking at, in some ways, you're just looking at number of hits to give you a sense of ligandability. But actually too many hits can also be a red flag. So usually you'd be looking at a kind of 0.5 to 2%-ish hit rate as normal. If you're seeing way more hits than that, that's probably telling you that something's not quite right, either in the reagent or the setup of the experiment. And as you rightly said, also in the techniques like SPR, where you have the ability to check for saturating binding, then obviously that gives you a good indication that you've got more specific binding events going on than the non-specific. So yeah, that's super important to look at.
And you mentioned running maybe multiple assays in parallel, maybe affinity selection mass spec or DELS and SPR, other biophysical approaches. How does this ligandability study inform on which assays might be best for that primary screen once you move these targets forward?
Yeah, so I've seen examples over the years where one approach is definitely more successful than the other. Obviously, your readout is different, but also your protein is in a different state in those different experiments, for example. So doing multiple approaches is helpful, and usually if one approach works in a kind of early ligandability study, then that's a fairly good indicator that it's going to work downstream as well. Things like SPR are really good for looking at weak binders, so fragment type compounds, for example. So that can be a nice route into to very early chemistry and early ligands. Obviously, DNA encoded library technology, you get real kind of diversity, a larger number of compounds, even in a small ligandability set. So sometimes that's good if you've got a less tractable target where you're going to get a very low hit rate, then that might be a good approach. But trying multiple things often is a good way to give you a good assessment of the target. It's probably also worth saying that a more ligandable target doesn't necessarily mean a better target. So this is usually about gathering information, as opposed to saying it's more ligandable, therefore it's better and you're definitely going to pursue it or not pursue it. As I say, it's about understanding the risk that you're carrying going into a kind of larger scale discovery project, and just kind of knowing what you're up against, whether you're going to have to run multiple techniques to find starting points, whether those binding approaches themselves can be used then for more hit finding, because often they're more rapid than developing kind of full scale functional or cell based screens. So if they work well, then that's a good route forward as well.
And I'm curious, do you have any stories, all non-confidential, of course, where maybe you learned something from a ligandability study that allowed you to make a decision to either pivot for a drug discovery program, maybe stop, or to give you more confidence in moving forward?
Yeah, I mean, obviously I won't speak about specific projects, but in general terms, I think over the years I've seen several examples where we had a target that was perhaps anticipated to be very challenging from a ligandability point of view, and actually it's worth saying that we are working on more and more novel targets. As we're using more kind of multi-omics approaches for target discovery, we're finding novel targets, novel pathways. We're guided by human genetics, but we don't often now know a huge amount about the targets that we're working on in many cases. So I think this is becoming more of a useful approach to help us get some insight into the ligandability that we may not otherwise have had. If you're working on a kinase target, you're pretty sure it's going to be ligandable, but we don't work on quite so many well precedented target classes like that any more across the industry. So I've seen a number of occasions where actually it's given us more confidence because we didn't really know much about the target, or it was expected to be less tractable or less ligandable, and then actually we saw nice ligandability, and that gives you confidence then to put the resources on and really go full steam ahead. On the flip side, we were talking about like the different approaches giving you different answers, and had a few examples where actually some of the approaches didn't really yield any hits or anything that looked like you might be able to take it forward into a drug discovery campaign, but maybe one of the approaches did. So SPR, for example, in one case, found us some nice early molecules, and so as you mentioned earlier, that then informs which approaches we're going to use going forward. So maybe in that case, going down more of a fragment screening route using biophysics is the right way to go. So yes, a few different examples of how it's informed, not necessarily, and I don't think often it's not like a binary yes you go or no you don't, but more about helping to steer and either build confidence or let you know that this one's going to be a challenging one.
Yeah, and I love listening to you talk, because it's clear that you also have a very good understanding of what different assays ask, what types of questions they can answer, and using that to inform on how do you interpret the results, how do you choose which assay format to move forward, and being able to de-risk using this type of ligandability study early on is a great strategy, and something that I think a lot of researchers are going to be interested in hearing. So thank you very much, Mel, for sharing your insight. Always a pleasure to talk to you, and thank you again for your time today.
Yeah, no, great to talk to you, Zach. Thank you.